Hello, welcome to my YouTube channel. In this video, we'll learn the relational data model. It is presumed that you have already known the ER model, the mapping rules from ER model to relations, and you know that the relational model is based upon the mathematical concepts of relations, set theory, and predicate logic. This model was first proposed by the British mathematician E.F. Coate from IBM. The first commercial implementations of relational model become available in early 1980s. Example, your SQL DS from IBM, Oracle DBMS. The popular relational database system tools includes your DB2 from IBM, Oracle, like Microsoft SQL Server, your MariaDB, Snowflake, MySQL, Amazon Redshift, Microsoft Access, and many more. The discussion point that includes your motivation of this relational model, the concepts of relation and relational model, which includes your definition, terminology, and characteristics. After that, we'll learn the data integrity constraints, which include your entity integrity and key constraint, domain constraint, your referential integrity constraint, and your assertions and triggers. What is the motivation behind this relational model? Let us first learn. What we get are the end of conceptual modeling phase. Initially, when you are asked to develop the database system of any enterprise, you have to collect all the data. Their characteristics you have to understand, the relationship that exists among the different data items, then what type of consistency constraints are there also that you have to collect. So we first draw the ER model. So this is a very powerful tool that is being used at the conceptual modeling of any database system. Look at here, it's a very small diagram we have taken. This is an example of ER model that includes your entities and their characteristics, the relationships, the consistency constraints. In fact, we get a reasonably understandable picture of data requirements for application system at a higher level of abstraction. And since it's a diagrammatic representation, we cannot implement. So that's why the conceptual data modeling phase is a technology independent. The next phase is your logical data modeling phase. In this phase, what we do, we map the ER model to tables, or it is called relations. And remember, these relations can directly be implemented using any of the relational database management tools, but the relations may suffer from redundancy because redundancy may lead the different type of anomalies like insertion anomaly, your deletion anomaly, or it may be leads to your modification anomaly. So further refinement may be required to eliminate data redundancy in the design, and that can be possible using your normalization techniques. So since these relations can directly be implemented, we call this phase as a technology dependent phase. Now let us learn what is relation, what is relational model, what are the definition, the characteristics, and the terminology that are being used for the relations we will learn. So what is a relation? We'll learn in fact two definitions. The definition one is that a relation small r based on schema capital R is a two-dimensional table, consists of rows as well as columns. Look at here, this is my relation, consists of rows and columns, and it is based on the schema that is called capital R, A, B, C, D. That's why what we write, that we write R of R. That means small r is the relation and it is based on the schema capital R that consists of the attributes A, B, C, D. Then another term is that what is a domain? Domain of a column or domain of a attribute is nothing but it is a set of permitted values of that column or that attribute. So if we'll say domain of A, domain of B, look at your domain of A will consist of your A1, A2, A3, A4, A5. These are the set of permitted values. Once it is a set, it is a collection of all the distinct elements. Look at the domain of B consists of B1, B2, B3, B4. But this B1 I will not repeat because it is a set. So we write what is the domain of B? Domain of B consists of B1, B2, B3, B4. Similarly, domain of C becomes C1, C2, C3, C4. That of D is equal to D1, D2, and D4. Look at your D1, D2, and D4 because D2 appears twice and D1 also appears twice. Now the second definition of relation is that a relation is nothing but it is a subset of the Cartesian product of list of domains. Now let us take two domains. Domain of A consists of A1, A2, A3, and that of B consists of B1, B2. Now if we'll go for the Cartesian product of A and B, we write A cross B, that is nothing but based on two values of A and B. We write, look at here, A and B. Each value of A will join with each and every value of B. That means A1 join with B1 and A1 join with B2. Similarly, your A2 also join with B1 and B2, and your A3 also join with B1 and B2. I mean, the number of values that we have created here is equal to 3 into 2, that is called for 6. 6 number of tuples we have generated. Now let us take any subset of this Cartesian product. Let us take A1, B1, A2, B2, and your A3, B1. Now this subset we call as a small r. This is a subset of your what? Your A cross B. And this help us to understand this definition of the second definition of relation is that a relation is nothing but it is a subset of the Cartesian product of list of domains. In general, we can write, look at here, R is a subset of D1 cross D2 cross up to cross Dn. That means the domain of n number of attributes. Okay. Now, another very important concept of relation is called the degree and cardinality. What is a degree? Degree is nothing but it is the number of attributes or the number of columns. That is also called arity. Similarly, the cardinality is nothing but the number of tuples or rows in that relation. Look at here. We have here 1, 2, 3, 4, 4 number of your attributes that indicates the degree is equal to 4. We have 5 number of tuples that indicates your cardinality is equal to 5. And sometimes we define also relation schema capital R. I mean, this schema capital R is nothing but it is a named collection of attributes, RC. What doesn't be what it means? Your RC, your C is a set N1, D1, N2, D2, N and Dn. That means the N, each N indicates the name of the attribute and the D indicates your domain. One example of relation, let us take customer. Customer is a table or it is called a relation, and the name of the relation is called customer. The schema is consist of customer ID, customer name, customer street, and customer city. This is called customer schema or scheme. And the number of tuples here is equal to 3, and number of attributes are customer ID, customer name, street, and city, that is equal to 4. The domain of a customer ID here, we can say that set of all the permitted values of the customer ID here, C1001, C1002, C1003. Similarly, the domain of customer name consists of Alok Kumar, Vijay Kumar, and Chinmaya. Similarly, the domain of customer city, look at here, Bhubaneswar, 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 but we'll write only one Bhubaneswar because domain is a set. Set is a collection of distinct elements. Next is characteristics of relation. Look at here, the first characteristics is that attribute name must be distinct. Look at here, the customer ID, customer name, street, city. Each and every attribute name must be distinct inside a relation. The second one is that all tuples must be distinct, and that we can achieve through the definition of a what? A primary key. Similarly, the third one is called the intersection of each row and each column must contain a atomic value. Look at here, the intersection of each row, each column must consist of what? Single values. Either you can put a null or you have to put a what? Single value. Now that says that the domain of each column should be atomic. The fourth one is that the order of rows and order of columns are insignificant to the definition of the relation. If you would like to sort all the tuples in the ascending order or descending order of any attribute, it will not change the definition of the relation. Similarly, if you would like to rearrange the attributes in a different order, that will also not change the definition of the relation. What are the characteristics of relation? Look at here, the second example we will take. Domain, as I told, domain must be atomic. What is a domain? Domain is a set of permitted values and it must be atomic. Let us take the example of employee. Another table consists of 3 number of your rows and 3 number of columns. In this case, the domain of employee ID will be consist of what? All the values of that attribute, that is called employee ID. So domain of employee ID is equal to E1001, E1002, E1003. It is a set of values. By that way, it is called atomic. Similarly, the domain of employee name consists of, particularly in this example, Rakesh Kumar, Sanjeev Kumar, and Rajesh Kumar, and it is a set of values. That's why it is called atomic. But if you look at the skill, the domain of skill, look at here, it is a set of values where each and every value is another set. Look at here. The set consists of C, C++ is one set, C, Oracle another set, C++ Java another set. So we call this is non-atomic because it is a set of another set of values. Now the domain is non-atomic. So then what is the solution? Because our requirement is that the intersection of each row and each column should be atomic. In that case, what we have to do? We have to go for a 1NF decomposition. That is called fast normal form decomposition that we'll learn during normalization chapter. But look at here how we decompose this one. We can create two tables in this case. The first table consists of all the attributes excluding the multi-valued attribute that is called skill. The second one is what? Takes the primary key of the first one and the multi-valued attribute. Look at here. This here employee ID is the primary key. And in the second table, employee ID skill combinedly defines the primary key for the second relation. And we can name it as a first one is employee, second table is called employee skill. Employee ID here serves as a what? Foreign key referencing to the employee ID of the one employee table. Now the domain is atomic for each attribute of both relations. So by that way, this relation satisfies our characteristics that the intersection of each row and each column must contain a single value or may possibly a null value. So entity set versus relation. Look at here. Let us take one example of an entity set, that is customer, consists of 4 number of attributes named as customer ID, cost name, cost street, and cost city. If you would like to map to tables, the rule says that you create a relation whose name should match with the name of that entity set, that is called customer, and include all the attributes as the attributes of that relation, that is cost ID, cost name, cost street, and cost city. And in this case, look at here, each row is nothing but that represents relationship among a set of values. And here every row indicates an entity, whereas the table itself indicates what, or represents the entity set. What is a relational model? So relational model is nothing but it's a collection of relations or tables. Let us take one example. Suppose we have a collection of tables like customer table, account table, deposit table of any banking system, and this collection is called relational model. And remember, in a relational model, each and every table name must be distinct. And if you'd like to know further, you can refer my one of the another video link that is given here, where we have described that how the ER model can be mapped to tables and how those tables can be implemented using Oracle. What is a data integrity constraint? Let us learn different data integrity constraints, but before that, let us learn what is a definition of data integrity constraint. So these are nothing but the rules governing the behavior of data at all times in a database system. Sometimes we call these are the technical expressions of business rules that emerge from the user requirement specification for database applications. And we want these rules must prevail across all tiers of data modeling: conceptual, physiological, and physical data modeling. Remember, this relational database system is popular because it has the rich capability of specifying different type of integrity constraints. The data integrity constraints can be classified as your entity integrity and key constraints, your domain constraint, referential integrity constraint, operational constraints. What is entity integrity and key constraint? Every relation in a relational database system must have a primary key, and that the domain of that primary key must be not null. At the same time, it must be unique. What is a domain constraint? The domain of each and every column must have a name, must have a type, must have a size, and must have a permitted set of values. It may be a range of values, it may be unique, it may be not null. Similarly, your referential integrity constraints are nothing but the consistency among the rows of two different tables can be maintained through a reference. That is called your foreign key to primary key. And operational constraints are nothing but the constraints enforced in the database by the business rules. we'll learn your assertions, triggers. They fall under the category of what? Operational constraints. So what is a entity integrity and key constraints? As you know that every relation must have a primary key and the domain of that primary key must be not null. Here branch is a relation and with a branch name as a primary key. By that the domain of the branch name must be not null, at the same time it must be unique. Similarly, we can declare another table that is called account, and your account number is a primary key, and by that the domain of account number must be not null, at the same time it must be unique. Let us go for the domain constraints. So what is a domain constraint? Every column must have a domain, and the domain has a name, type, size, permitted values. Look at here. We have a domain for branch name, we have a domain for branch city. So how we declare using Oracle? We write create table branch name, character 6 primary key, branch city varchar to 15. Look at here the domain, each domain has a name that is called branch name in this case. It has a type that is called character. It has a size that is called 6. It has a primary key, that means this primary key what says that it must have a permitted values that is called not null, at the same time it must be unique. Similarly, for the city, we can also define a domain constraint. Look at here. We write create table branch name, character 6 primary key. The branch city is a varchar to 15. We write through check constraint branch city in Delhi, Mumbai, Bhubaneswar. I mean, the system will not allow to enter any value other than Delhi, Mumbai, Bhubaneswar. If somebody is like to insert like Chennai or Kolkata, or in short write BBSR, or instead of Delhi, let's say New Delhi, the system will not accept. Sometimes we can make it as a default value. Look at a create table branch name, it is a primary key, branch city varchar to 15, default Delhi. If the user is not entering any value, by default system will accept Delhi. Otherwise, if you like to insert a value, the value must be either Delhi or Mumbai or Bhubaneswar. So this way we can say that my values should be this range of values, or these are the possible values I would like to insert. That is called domain constraint. So referential integrity constraints. Look at here. Let us take the example of two tables. One is called branch, second is called account. Branch name is the primary key of the branch table. Account number is a primary key in the account. Now we declare branch name in account is a foreign key referencing to the primary key branch name of branch. In that case, what a value we can put as against the branch name in the account table. The value must be present in the domain of the primary key to which it references. Either we can insert either KIIT or IIIT. Either you can put a null, but if you are not putting a null, but if you would like to put a value, the value must be present in the domain of the primary key to which it references. And the foreign key may contain a null, but if the foreign key is a part of the primary key, or if the foreign key it has been declared explicitly that it is not null, then you cannot insert a null value. Look at here how we implement this one. We write create table account. Account number is a primary key. Balance, we declare a domain that balance check balance greater than 0. And the branch name, it is a foreign key. We write character 6. I mean, character 6 must be the type and size of the branch name, that primary key of the branch to which it references. We write the keyword that is references, table name, and the primary key attribute name, that is branch name. So by that way, we create what? We establish the referential integrity constraint by referring the foreign key to the primary key. Now here we have written so note, a foreign key can either be null if it is not a part of the composite primary key, or it contains a value which is present in the domain of the primary key to which it references. What is the operational constraints? These are the business rules, and it can be classified as two types. One is called application based procedural constraints, or it may be a DBMS based procedural constraints, like your assertions, triggers. What is assertion? Assertion is nothing but is a predicate expressing a condition that we wish the database always to satisfy. And your domain constraint, your referential integrity constraints, these are the special form of assertions. For example, in a branch of a banking system, the sum total of loan amount should not exceed the sum total of deposits in that branch. So this can be implemented using one assertion. What is a trigger? A trigger is a statement that is executed automatically by the system as a side effect of a modification to the database. That's why we say triggers are fired automatically as a side effect. Then what are the requirements for designing a trigger? That you have to specify the condition under which the trigger must be fired. And once it is fired, what action the system is going to take. That also, these two requirements we have to specify while designing a trigger. Let us take one example. We have an employee table consists of 6 number of tuples, and we want to create a transaction history table, and any user is going to either delete or update any tuple of the employee table that we would like to record it in the transaction history table. That means the table name, here table name must be employee, the transaction type either delete or let's say update or modification, and the username, the user who is going to do the delete or update operation, and the date of transaction. And for that, how to create this transaction history table? We write create table trans history, table name varchar to 15, transaction type we write varchar to 15, username varchar to 15, and transaction date is a date type. Table is created. Now let us create the trigger that is called employee edu trigger. And look at here, we write create or replace trigger employee edu trigger after delete or update on employee. Edu stands for what? After delete or update. Now declare v transaction type. We declare a transaction type begin. If deleting, v transaction type should be delete. If updating, the transaction type should be update. After that, we insert in that transaction history table that we have created. Insert into transaction history values. The table name is employee. The transaction type v type either delete or update. Then the username and the system date. What are the effect of triggers? Let us learn the effect of triggers. Let us update one record, like update employee, set city is equal to New Delhi, where employee is equal to U1001. One row is updated. Let us see the content of trans history. Now look at here, one record is created. The employee, the table name is equal to employee. The transaction type is equal to update. The username is CAC2022. The date of that transaction is 7th February 2022. Let us delete from employee where employee ID is U1001. One row is deleted. So by that, let us see what is the content of your trans history. Now another record also inserted here. The transaction table name is called employee. The type of operation is called delete. Transaction type is delete. Username is CAC2022. And the transaction date is 7th February 2022.